So we have 3 kilograms of chain that is replacing the cart in the last problem, right? So now that we have a 3 kilogram chain, at t equals 0, the system is released from rest. Calculate the acceleration of the system the instant the system is released. Explain your calculations with words. So what's different about a chain? Well, a chain is going to hit the ground eventually, and that's going to change the acceleration a little bit. Let's see. So let's get to it. The acceleration we can find from free body diagram. We can do one for each object and then combine them, or we can do the one for the system. I'm going to do the one for the system. The stuff that makes it go is going to be the weight of the chain, because the bearings are frictionless. For the cart, we won't have anything holding it back, so our net force is just going to be the weight. So mg of that equals mass of the system times acceleration. So we have 30 over here, and then mass of the system is 6. So we get A equals 5 meters per second squared. Now, explain your calculations with words. I think I did that. I'm not going to take up your time and redo that. Write a brief paragraph explaining how the acceleration and velocity of the system are changing, whether it's increasing, decreasing, or staying the same as the chain goes from the first touching the ground to completely being on the ground. Explain your reasoning by citing appropriate internal and external forces and physical principles. All right. Let's start with acceleration. For the acceleration, when each chain touches the ground down here, right, so this goes a little bit further down, and then we have all these chains touching the ground. As that happens, our free body diagram for the system is changing also. So we still have the weight of the chain, so we still have Fw pulling it down, and then down here, we're also getting this normal force. And with each link that touches the ground, our normal force is going to increase. Right? Exaggerated there to show the effects. But what's that going to do to the acceleration? Acceleration is going to decrease. Decrease because at each chain, each link, creates not a great word. So a normal force will act in the opposite direction. Changing the net force. Meanwhile, what's the velocity doing? Well, what direction is our acceleration? The net acceleration is still acting down. Our velocity is going down because the net force is down. Still, the cart will speed up. So just because our chain is touching the ground, that doesn't mean the cart's going to change its motion, right? It's still going to move and it's going to speed up because velocity and acceleration in the same direction lead to an increase in speed.